Let's see another problem based on recursion, backtracking, and target subarray. Let's understand the problem and then we'll see how we get the solution. So this is the problem. It's a combination sum, and what we want, let's understand the problem. Given an array of distinct integers, candidates, and target integer target, return a list of all unique combinations of candidates where the chosen number sum to target. You may return the combinations in any order. So if you see here in the input, there is an array and there is a target 7. So we want all the combinations that becomes 7 when we add that number. So 2 to 3, so output is a 2 2 4 and 3 7, and it's a 7 itself. And one more thing, if you see here, the same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen number is different. So that's why if you see here, 2 is repeated. So in order to make 7, this number or any number in this list can be repeated many times. So we need this output. So from here 2 2 3 7, and this there's a one combination and another combination is 7. So how to solve this kind of problem? So there are a few techniques, and we have to know that techniques in order to solve this kind of problem. We'll see many similar problems based on this technique, but first try to solve this. Okay, so we'll understand as I write the code, and from there we can see the techniques there. Okay, so I'm just going to declare a variable index is equal to 0, and there is a result, and the result contains this result what we want to return here. So result int, I can say I can define the variable like this. I need some data structure, let's say ds, and it's the int. Let's define this way, ds int. Okay, yeah, we'll get surprised what we need, why we need ds and result. It makes sense after a few lines, and we can deep dive into this. Okay, so I'm going to write a function like, let's say csum, where I can pass candidates, and then I can pass this index. I want to start with index 0, so index, and then target, and result, and then ds. And the main logic is here in this function, and I want to okay, so one thing, result I'm passing here, so I'm passing the address. That's why this function, whenever the function calculate the result, it will add that result, and at the end I can return the result. Okay, so come here, it's a function csum candidates, type is int, then there's the index, type is int, the target, I can pass this add result or result, so this star I can put it here, index, and then target is int. After target there is a result. Okay, so result is star of int, then ds, that's the int. Okay, so for this solutions, what we need to understand, we need one thing is, this number can be repeated in the solutions. So we want to try with the many combinations of the number itself. So that's why when we call the recursion, in the recursion we can call this number again and again, as long as the sum of that number equal to 7, and if it is greater than 7, it will come out. So that is the one thing. And then also we want to try with this number with another number. So one pattern is, if you see the index can be same, so that's why, and we can call the recursion, then in that way we can try with all the combinations of this number. And another pattern is, we also want to try with other numbers, so in that case we can move the index. So we need at least 2 recursions. So just I'm saying, okay, see sum, and I'll modify this later, but now passing index, target, result, and then ds. So I need to call this again and again, one with is the same index and one with is next index. So same, if I call this recursion with the same index, that means I'm calling with each number again and again. Try the combinations with the same 2, 2, 2 and see whether we get this 7 or not, and then after that 2 and the next number. So that's why index with the same number, keep going, and index plus 1 next number. Okay, so if we call the recursion index, then there will be some base condition, exit condition, like when it should be out. So once I'm saying, okay, index sometime, the index, when we do the index plus 1, sometime it's reached to the length of these candidates, and that's a base condition. So I can say if index equal to length of candidates, in this case return. Okay, so that's one thing. This is C sum, S is upper. So when I call this C sum, so the pattern we found, index for the same number, try with the same number, index 1, try with the same number, another number. So this is the two the function call we found here. We also want to check something here, like let's say when we call this number, then we can say the if the candidates index is less than target, then only call this. If the candidate index, so we'll try with 2, and then 2 is less than target 7, then we can call this function with the same index. Again it will try with 2, and then in this time the target will be different, because first we try with 2, then we have to do the new target will be target minus this 2. So the new target we can set here, it's a target minus candidates index. So in this way we keep trying with this, and sometimes it's a it becomes 0. If the target becomes 0, then we get the result. So so in that case, let's see this condition, like if target equal to 0. Okay, so if target is 0, then we need to do something. But here in this case, like let's collect the result, that item. So if the target index less than target, we can call this number, but we can also add this in a result. So ds and ds and candidates index. Okay, so this number, like if the candidates, if I try with the 2 and the 2 less than the target, that's a 7. So we can add this in a data structure, and again we can call for the same number. So try with the same number combinations, and then when this work is done, there is a backtracking. So the backtracking is, we can get rid of this number here, like the ds, whatever we added in a ds, we can remove from the ds. So ds equal to 0, 2, the length of ds minus 1. So this is called the backtracking. Okay, and in this case, when the target equal to 0, we keep collecting all the numbers in a ds, and that numbers we want to add in a result. So let's create another variable, make int length of ds, copy whatever we collected in ds in a ds2. So copy ds2 ds, and then we can add this in a result. So result append result equal to ds2. Okay, that's good here, and I think that's all the solutions. Let's try this and try to run and check for any syntax error. So compile time error. So okay, we need this variable here, ds. Try one more time. See some cannot use the result variable. Okay, so we need to pass the address. Let's try one more time. Okay, so this is the pointer, so that means we need this star here. I think this would run this time. Wrong answer. Let's analyze why it is the wrong answer. So output is this. So let's see the conditions once again. So index less than candidates, then in that case, if the target, that's a return, and if the target equal to 0, then ds2 int length ds, we want to make the same size ds2 and copy ds2 and we can add this result here and return. Okay, so this would be like less than equal to conditions. The candidates index less than equal to target, then do this thing. Try one more time. Accepted, submit. Okay, nice. So that the answer is accepted. Let's see Java solutions for this. So it's the same logic for the Java also. It's a combination sum here, and we see sum. We have defined the data structure and the result, and if the index is equal to candidate's length, and we're also checking target 0, then we can add this result here, and we have like two call. One is for the same number, so that's why you can see the index same, and we are calculating the new target here. And in this case, you can try with other number. So that's all for today. Thank you.